Hello everyone, welcome to OOkul. So let's continue this journey of simple mechanisms, or we should say the theory of machines, with this lecture, that is simple mechanisms part 4. So before proceeding further, let me just remind you, if you haven't subscribed to our channel, please do it at the earliest and also press the bell icon so that you can get the notifications of all our newly uploaded videos from time to time. Okay, so let us begin with this. In the previous lectures, we have seen the concepts of this simple mechanisms, like what are the joints, what are the links, what are the types of relative motions, and also we have seen the concept, a very important concept, of degrees of freedom, and also we have seen in the just previous lecture like your 4-bar mechanism and its inversion. So today we will be moving on with the single slider mechanism, single slider crank mechanism and its inversion. Okay, so let us start. It says, what is a single slider crank mechanism? It says it is a mechanism which consists of 4 links. Okay, it consists of a 4 links, so it's again a 4-bar mechanism, but the thing is it is connected by 3 turning pairs and 1 sliding pair. In the 4-bar mechanism, the simple 4-bar mechanism, there were 4 turning pairs only, but here there are 3 turning pairs and 1 sliding pair. You can see this is your link 1, that is your fixed link, which is either the cylinder and also this point which is at fixed. Okay, the second one is your crank. Okay, the third is your connecting rod, and fourth is your piston or the slider. So here you can clearly see that your crank, which is the smallest link, is adjacent to your fixed link. So we clearly know from the Grashoff's law, from the criteria of the Grashoff's law, that this will be a crank rocker mechanism. Okay, so simple single slider crank mechanism is a crank rocker mechanism that you can already see. In this, the crank will undergo the complete rotation, whereas the slider will do the reciprocating motion. Okay, now see its inversions. The inversions of the single slider crank mechanism, there are different kinds of inversions when we fix different types of elements. Okay, so when the crank is fixed, we get 2 mechanisms which are known as your Whitworth quick return motion mechanism, and the second one is your rotary internal combustion engine mechanism. Okay, that is also known as a Gnome engine. Then if the connecting rod is fixed, we get another mechanisms, that is your crank and slotted lever quick return motion mechanism, and the second one is oscillating cylinder engine mechanism. Okay, and when the piston or the slider is fixed, then we get the hand pump mechanism, which is also known as a pendulum pump or a bull engine. Okay, so now we will discuss all of them one by one. So let us begin with the first one, that is your Whitworth quick return motion mechanism. Okay, so before going into the analysis part of this, let us see the video of this. Let us understand it through this animation or this video, so that we can understand that how this quick return motion mechanism works. Okay, so let us see this one. See this. In this you can see that the backward stroke or the backward motion or the return motion is very much faster as compared to your forward stroke or the cutting stroke. Okay, see, this is very much obvious to you, this is very much clear to you. Okay, have you seen it, or just see it once again? I am showing you once again, let us see it. Okay, so you can see that the forward motion is very slow, whereas the return stroke or the backward stroke is very fast. Okay, this is very absolutely clear. Now let us see the analysis part of it through this diagram. Okay, now come to this. See in this, the basic mechanism of the crank slider, that is your this is your crank, that is denoted by 1. This is fixed. Okay, so now you can say that the smallest one is fixed, the smallest link is fixed, so you can clearly say that we get a double crank mechanism. Absolutely correct. Okay, now this BC is basically a slotted bar, inside which this connecting rod, this AB is your connecting rod, this will move. Okay, or this is the slider, that has been shown to you. So this will move inside this slotted bar. Okay, and also this your AB is your connecting rod. Okay, so the slider will move inside this rod, and this B position will move on your outer circle or your bigger circle, whereas this C is just the opposite point that will move inside your inner circle or the smaller circle. Clear? Now you can see when this position of B will be at B1, your this position of C will be at C1. Okay, and when your position of B will be at B2, then your position of C will be at C2. Okay, so from B1 to B2, if we talk about from B1 to B2 or from C1 to C2, this will be your cutting stroke, that is given by the angle alpha. This total angle alpha is also known as your cutting angle. Okay, this is your cutting angle. Whereas if you see, when the position of B changes from B2 to B1, your position of C changes from C2 to C1. That means it covers an angle of alpha, and that is basically your cutting angle. Okay, this is basically your cutting, sorry, this is your return angle, or you can say, yes, it is a return angle. Okay, this is your return angle, and you can say that clearly you can see from here that this return angle alpha is less than, beta. So that's why we call it that it is a quick return mechanism. It's a quick return motion mechanism in which the time taken for the return stroke is very small as compared to that of the cutting stroke or the forward stroke. Okay, this is absolutely clear to you. And we have one more thing, the relations between alpha and beta, that is alpha plus beta is always equal to your 360 degrees. Okay, alpha is less than beta and alpha plus beta is equal to 360 degrees. Then we have one more thing, that is your time taken for the forward motion divided by the time taken for the backward motion, or you can also write it that the time taken for the cutting stroke, okay, time taken for the cutting stroke over the time taken for the return stroke. Time taken for the return stroke is equal to your beta by alpha. Okay, beta by alpha, as I already told you that the cutting motion takes more time whereas the return takes less time, hence the name, it's a quick return one. Okay, and this ratio is always greater than 1, and this ratio is known as QRR, that is quick return ratio. Please remember, this is known as quick return ratio and it is always greater than 1. Okay, now what is your stroke length? The stroke length is given by R1. Okay, it is absolutely given by R1, R2. Clear that because the ram, that the tool moves from R1 to R2, these are the two extreme positions of this tool. So stroke length is equal to R1, which is nothing but, which is equal to your C1, C2. Okay, R1, R2 and C1, C2. And C1, C2 is nothing but twice of, you can say it is twice of OC1. Okay, it is twice of OC1, or you can also write it twice of OC. Okay, it is twice of OC. So this is nothing but twice the radius of the smaller circle. You can clearly see that twice OC or OC1 or OC2, or you can say twice OC. This is nothing but your twice of radius of a smaller circle, or you can also say it is the radius of the smaller circle. So there are very less variations we can do in the change of a stroke length for this case. So basically this is the very limited thing which we have, or we can say that this is the basic limitation of this Whitworth quick return motion mechanism, that the variation in stroke length are limited because it is dependent only upon your one variable, that is your diameter, or you can say the radius of your smaller circle. Clear? So limitation is the variation in the stroke lengths are limited. Okay, so you have already seen it through this video. Next, move on to the another inversion of this same mechanism, that is your single slider crank mechanism. When your crank is fixed, in this is known as a rotary internal combustion engine mechanism, or also known as a Gnome engine, in which this link 1, that is your crank, is fixed. Okay, and if this crank is fixed, so you know that this crank is the smallest one and it is fixed, so it again becomes your double crank mechanism. Okay, it becomes a crank mechanism or a double crank mechanism. It works on a similar ways as of this. Okay, it is used in the aircraft engines where we get the high lift. Okay, where we get the high lift. Okay, now moves on to the mechanism or the inversions of the single slider crank mechanism, where your connecting rod is fixed. Connecting rod is fixed. You can see here this AB is your connecting rod, or sorry, this point, that is your point AB is fixed. Okay, this point AB is fixed, or you can say that this is your connecting rod. Okay, or you can write it as O also. So you can say that OA is fixed. Okay, where yours this thing, that is OB1 and OB2 are your crank. And now you can say clearly that your crank, which is your smallest link, is adjacent to fix. It is adjacent to fix, and by the Grashoff's concept, the Grashoff's law, we know that in this case we get a crank rocker mechanism. Okay, now again this beta is your cutting angle. Okay, this is your cutting angle, and your alpha, this is shown, this beta is your greater one, and this alpha that has been shown, alpha is your return angle. This alpha is your return angle. Okay, absolutely clear. And you know that alpha is less than beta, and also that alpha plus beta is equal to 360 degree. This also is valid. Clear? Now let us see the analysis of this thing. That is, in this there is a slotted bar. When this point B is on B1, this point C will be at C1, okay, and when this point B is at B2, this point C will be at C2. So you can say that the stroke length will be equal to R1 R2, or you can also say it is equal to C1 C2. It is clear that it is equal to C1 C2, and also in this case the quick return ratio remains the same, that is beta by alpha, which is always greater than 1. Okay, the stroke length is equal to R1 R2, which is nothing but equal to C1 C2, that I have already told, and you can also write it twice of C1 into M. Okay, you can see the point C1 C1 M. So this basically the twice of this is equal to your stroke length. Clear? So you can write this as now this C1 M. If you see in this bigger triangle, that is A, C1 and M. Now you can see in this bigger triangle, this angle comes out to be alpha 90 minus alpha by 2. Okay, this will be alpha by 2. This angle is 90. So this becomes alpha 90 minus alpha by 2. Okay, so this you can write it as twice of AC1. This is your twice of AC1 because it is twice this. So C1M can be written as this thing. That is your AC1 into AC1 cos of alpha by 2. Okay, we can write it sine of 90 minus alpha by 2, that will become cos of alpha by 2. Okay, so this you can be written as twice of AC1 into this cos of alpha by 2. If you see in this smaller triangle, the alpha by 2, the cos of alpha by 2 can be written as OB1 divided by OA. Okay, you can clearly see that this is your OB1, this is your OB1 divided by OA, that is your base by hypotenuse, that becomes your cos alpha by 2. Okay, or you can write it as twice of AC into OB, twice of AC into OB divided by OA. Okay, what is this AC? This AC, you can say this AC is your length of the slotted bar. Okay, what is this OB? This OB is your length of crank, and what is OA? OA is your length of connecting rod. So there are basically few variations that are allowed in this case of a crank and slotted lever quick return motion mechanism. So we can say that this is the advantage that we overcome from the quick return motion mechanism. In that we saw that the variation in your stroke length was very limited, but here the stroke lengths are not limited. It depends upon 3 variables. So if we vary each of the variables, we can get different sort of stroke lengths. Okay, so please remember this concept, that is what is the stroke length for this case, and also your beta by alpha, which is always greater than 1 and which is nothing but your quick return ratio. Okay, I hope this is clear to you. If you want, you can see it through this video as well, that how it works. So let us see this. See this. See, this is your forward stroke. Clear? And see, now this is your backward stroke. See this. So you can yourself make it out that how much the difference is between the speeds of this forward mechanism or the forward motion and the backward motion. See this. See this very carefully. Okay. Yes. Absolutely clear. See this. Yes, the forward motion is a very slower one compared to your backward motion, and the backward stroke is very fast. Yes, see this. Okay, is this clear now? Okay, so let us proceed. Let us see. Let us come to another one. That is your third one. That is your oscillating cylinder engine mechanism. In oscillating cylinder engine mechanism, what happens? This is your crank. Okay, this is your crank, that is shown by the link 2. This is your fixed link, that is 1, and again your crank, which is your smallest link, is adjacent to the fixed link. So hence we get a crank rocker mechanism. Okay, we get a crank rocker mechanism. So let us understand it with the help of the video first. So let us see this. See this. This is this link. This link is your crank. Okay, you can see that this link is your crank one. Okay, and this one is your slider, which is fixed. This is your cylinder, which is oscillating. Okay, and this is the line of the slider. Basically, this one is your line of the slider. This is your crank. Okay, and this is your piston or the slider which is moving. So let us see it once again, that how does it work. See, then you will have the idea yourself. Yes, absolutely fine. Is any problem into this? You can ask me in the comment section below. I don't think that there will be any problem. Okay, so if you have any problem in understanding any of these mechanisms, you can personally contact us through the comment section below, or also through our Facebook page, Twitter page, Telegram channel, or also through our website and email ID. Okay, so now let us move on to the next mechanism, that is known as your hand pump mechanism. Hand pump mechanism, which is also known as your bull engine mechanism or a pendulum pump. Okay, this is also known as your bull engine mechanism, or it is also known as a pendulum pump. Clear? So these are the two other names of this mechanism, that is your hand pump mechanism is also known by the name of bull engine mechanism or your pendulum pump. So this is also the inversion of a single slider crank mechanism in which your slider is fixed. Please remember, in this case the slider or this plunger is fixed. Okay, now in this mechanism, the cylinder of the basic mechanism, what was the cylinder of the basic mechanism, is replaced by a plunger and plunger rod as a link. Okay, the slider is fixed and is made hollow in such a way that the turning pair between the connecting rod and the slider pin, where is the connecting rod between the connecting rod, the turning pair between the connecting rod and the slider pin is not disturbed, and also some holes are made on the plane of material where pin which is attaching the connecting rod and the slider is there, so that water can pass through it. Basically we can say that there will be some holes on this part, okay, so that the water can pass through it. Okay, and the crank, this is your crank, it is extended to make the operating handle of the hand pump. So it has been extended here, so this becomes your operating handle of your hand pump, as you might have seen. Okay, now connecting rod is attached to the crank. The connecting rod is attached to the crank by the turning pair. So here also it is a turning pair, and the plunger rod is attached to the crank. This is your plunger rod. It is also connected to the crank by your turning pair. And okay, and the plunger slides within the slider. This is your plunger, it slides within the slider, so it moves here and there. It basically does a reciprocating motion. Okay, now when the handle, this handle is rotated downwards, what will happen? The plunger rod moves upward because this will be handled downwards, so this is fixed here. So the plunger rod will move upward, and the suction is created and the water comes out of the outlet. Okay, and the water comes out of the outlet, and when this goes upward, this moves downward and the suction is not created and the water does not comes outward. Okay, so this is basically a very important mechanism that is known as your hand pump mechanism or a bull engine or pendulum pump mechanism. So let us understand it in a better way with the help of this video. Okay, so let us have a look at it. See this. See, in this your handle is not shown. Okay, so basically you can say that the handle will be somewhat this side and it is attached to this point. Okay, so when this moves upward, so this will be going this way. Clear? I hope you are getting it. This is very easy to understand. Please have a look at it very carefully. Okay, see this. Yes, see this. Okay, so thank you for watching this one. So in this video, in this lecture, we have understood about the single slider crank mechanism and its inversions. Okay, we have also done the analysis part, and we have also have a look at them through your videos as well. Okay, the animations as well. Okay, so in the next class, only one topic is again left of this simple mechanism, that is your double slider crank mechanism, that we are going to discuss in the next video. Okay, so stay tuned for that video. Till then, keep sharing these videos, keep liking them, and also if you have any problem, any doubts, any comments regarding the content that we are posting, that you can write at us on the comment section below, or also you can join with us on our Facebook page, Twitter page, Telegram channel, and also you can write to us through our website or our email ID. So see you in the next video with the inversions and the basics of double slider crank mechanism. Till then, thank you and have a nice day.